Hello students, sorry I could not be here this morning. My daughter got sick. So let's go ahead and take notes as we go from the pink packet that you found in the front of the room. If there's a point in time you need to hit pause, just ask the teacher to do so in the room. So what we're going to do, our next unit is all about circles. We're going to get a little introduction to circles and the different parts of it, and specifically focusing on tangents. So let's take a look at a couple definitions. The first is what a circle is. So if you didn't know, a circle is the set of all points in a plane that are equidistant from a given point called the center of the circle. These are probably definitions you're probably already familiar with. The radius is the distance from the center to a point on the circle. To have congruent circles, these are circles that have the exact same radius. And the diameter is the distance across the circle through its center. So these were all written in because you were probably familiar with these. So let's take a look at a picture with this. So the center here is P, and if you look at the bottom here, we name it by using the letter of the center. So as you can see at the bottom in the middle, hold on one second, we have this symbol for circles. So just like with triangles, we use a triangle symbol. Just for parallelograms, we can use a parallelogram, so on and so forth. So this one here, we use that circle with a dot in the middle to name our actual circle. So the diameter is this whole line that goes across, and the radius is exactly half that amount there. These might not be new to, or these may or may not be new to you. So a chord is a segment whose endpoints are on the circle. So for example here, we have segment AB. So this is points going from A to B. It does not have to go through the center, which makes it different from the diameter. But the endpoints have to be on the circle. So segment AB here is a chord. You can go ahead and draw that in the circle that you were given on the left in your notes. A secant is a line that intersects the circle in 2 points. So this now is a line opposed to a line segment. So as you can see, it's continuing through the circle, indicated by our arrows here, and it's touching the circle in 2 exact points. One is here at point M, and the other one is at N. The next one is a tangent. Tangent is a line in the plane of a circle that intersects a circle in exactly 1 point. So this is what a tangent would look like. It's not going through the circle. We're intersecting right here. It may not be obvious to you, okay, but there technically is a point there, and that is called our point of tangency. Bring that back later. But again, it's going to be a line or it could be a segment, but in either case, it is only touching the circle at 1 point, and usually it's outside the circle. So here's our first example. If the substitute or the teacher could hit pause for a moment and have the students try this, give them about 2 or 3 minutes to name the different things. So let's take a look at segment AH. Segment AH is only intersecting the point at 1 spot. Therefore, it's a tangent. EI. EI is going from one end of the circle to the other, but it's going through the center, so this is a diameter. DF. It's touching the circle twice on the inside and is stopping there. It is not going through the center, so it is just a chord. CE goes from the center to the side, so therefore it is a radius. Our next definition are what tangent circles are. Tangent circles are coplanar circles that intersect in 1 point. So they look just like this. They're only touching right here. So as you can see, they're only intersecting at this one exact point right here. So these are tangent circles, just like a line that is tangent only touches 1 time. So they're only going to intersect at 1 point there. Concentric circles, like co-worker, coplanar, collinear, that means they're sharing the same thing. In this case, they are sharing the same center. So concentric circles are coplanar circles that have the same center. Moving on, we have ourselves a common tangent. So tangents hit circles only once. A common tangent is in relation to 2 circles. And this is a line or a segment that is tangent to 2 coplanar circles. A common internal tangent would be when they're intersecting in between the 2 circles. So it's a segment that joins the centers of the 2 circles. A common external tangent does not intersect the segment that joins the centers of the 2 circles. So these are on the outside. So this is what it means to be internal. Okay, so we have it in between the 2 circles that are provided for us, so that's the common internal. And the external is sitting on the outside. So we can have multiple external tangents. For example, this one is going to have on that side. We also have one that's going to lay on this side. And the internal, we can also draw another one going this direction. So there are multiple tangents that exist. So here's our second example. We want to tell whether they're internal or external. So looking at the first one here, we can see that they are lying in between the two circles here and here. So therefore, it's going to have to be an internal tangent. The other ones are on the outside. So since they're sitting on the outside, we're not going through the center at all. That's going to be common external tangents. The interior of a circle, I know this isn't sitting on your thing, just please listen for a second. If I tell you something about the interior of a circle, that's talking about the points that are inside the circle. If I ever mention the exterior of a circle, that's all the points that are on the outside of the circle. So that's just useful information. Again, I know it's not on there. Okay, the next one. I referenced this earlier before. It was called the point of tangency. And this is the point at which a tangent line intersects the circle to which it is tangent. So taking a look at a tangent line, so remember it only hits one time and it's on the outside. This point where it's hitting is called our point of tangency. So it's only going to be one in these. Here's our first theorem with this. If a line is tangent to a circle, then it is perpendicular to the radius drawn to the point of tangency. So what I mean by that is if I drew in our radius here, PQ, and I had a tangent that's going through that exact point, there is formed a right angle right here. And that's going to be very useful to us because we can form ourselves right triangles. And so there's a lot of properties of right triangles that exist. Okay, so these are the words if you would like to write those down. If I is tangent to circle Q, then P, at P, then I is perpendicular to segment QP. Remember, if we do an italicized I, that means that's the name of the line. Second one. In a plane, if a line is perpendicular to a radius of a circle at its endpoint on the circle, then the line is a tangent to the circle. So what that means here is if I give you a diagram like this and I see the right angle, you can automatically assume that that line there is tangent. So this again is the converse of what we just discussed. Our next example here is utilizing that. So I wanted to decide whether CE, so this line CE, is a tangent to that circle. And we have some important information. We know that this length is 11 and this length here is 45. So what we can then use here is the Pythagorean theorem. Remember, the converse is what determines whether we have an acute, an obtuse, or a right triangle. So the smallest lengths are going to go in for A and B. The biggest length is going to go in for C. So we have 11 squared plus 43 squared, and we're going to relate it to 45 squared. Squaring everything out and simplifying it, I can see that they are not equal, and that's all I need to see. So therefore, since it's not equal, it cannot be a right triangle. Since it's not a right triangle, that means the line segment CE cannot be tangent to the circle D. Our next theorem, if two segments from the same exterior point are tangent to a circle, then they are congruent. So what this is saying here is I've drawn in two tangent lines, and I can tell they're tangent because they're intersecting only at one point. What it's saying is that the distance from R to S and T to S, those two distances are going to be equal. So that's exactly what it's saying down here. If line SR and ST are tangent to circle P, then segment SR is congruent to segment ST. So we can do a lot with that as well if we are given pieces of information on those. So those pieces are going to be equal. And also keep in mind that we do have right triangles here. So if there's ever any problems that have a line down the middle, we know that we have ourselves not only two congruent triangles here, but two right triangles. So let's do an example here. I would like for you to try this on your own. If the substitute or teacher can hit pause and let the student try it first. After about 2 or 3 minutes, go ahead and hit the play button. Okay, so our goal here is to find the value of x. I'm told in the directions that these two segments here are tangents. So what that tells me is that these two pieces are going to be equal. So what I'll do is set x squared plus 2 equal to 11. I'm going to subtract 2 from both sides and then take the square root. The reason it's both positive and negative 3 is because if I were to substitute 3 or negative 3 back in for x squared, I'll get a positive 9. So for those of you who just said 3, you're missing your second answer. For those of you who said positive and negative 3, good job. Now just keep in mind that's not going to happen every time. If we had something down here that say 2x plus 3, something like that, then it wouldn't work with a negative because then this would actually come out to be negative 3, and we can't have negative distances. I would like for you to please complete this exit slip and turn it into the box at the front. What I want you to do is keep in mind I know we didn't do a warm-up here, but what we need to do is use FOIL. Here's my hint to you. If I have something like x plus 4 squared, you need to write it twice, like this, and x plus 4, and then you need to multiply those two things. FOIL might be something that's familiar to some of you, and the box method is something that might be familiar to you. So go ahead and give this a try, tuck it together, and make sure you turn in this one problem. Have a great weekend, and I will see you next week.